Hi guys, this is Mrs. Foy, and this is a quick tutorial, about acids. All right. So acids are what? They are chemicals that taste sour. They are um, compounds that have hydrogen as their cation, and there are actually other definitions of an acid that are more advanced than this one, but for our first year chemistry course, this one works. All right. And so we're going to talk about the way that we name acids, right? So hydrogens as their cation. What happens is that if you have the most famous acid, this is hydrochloric acid, a lot of times we will write the little subscript AQ. And AQ means aqueous. And in a lot of acids, we write it like this because what it means is that it means that in water, what hydrochloric acid does is it ionizes and breaks apart into hydrogen proton and chloride ion. And this is what makes it an acid. So anything that increases the concentration of this H plus is an acid. All right. So that's kind of the a very simple definition of an acid. And now we're going to talk about naming acids. So see how this one says hydrochloric acid and this one says sulfuric acid. There's no hydro in it at all. So you should have watched a ed puzzle about this acid nomenclature, but I'm just going to give you the quickened version of this, okay? So there are basically two kinds of acids, all right? There are what we call binary acids, and there are what we call oxyacids, all right? So let's start with the binary acids. Binary acid, binary means two. So this literally means there's two elements in the acid. We know one of them is going to be an H. So the other one is going to be some type of anion. And so, for example, I can think of anions like Cl minus. We know this is going to be a hydrogen proton, like sulfide ion, phosphide ion, all right, just to kind of give you three of these to get this. So now if I were going to write the formula for these, I would see the first one is HCl, the second one is H2S, and the third one is H3P, right? So I need to balance out my cations and anions just like I normally do. Do you guys see how each of these has two different atoms in it? That's what the binary comes from. And so the way that you name binary acids is you say the name of the other element that's not hydrogen. You add the prefix hydro and you add the suffix ic. So all these are going to be hydro, whatever the other element in is, ic acid. Okay, so we would call this hydrochloric acid. And technically you would write parentheses AQ here, but it's just a small thing. This would be hydrosulfuric acid. I'm just following the pattern here. And again, it's good to put AQ because technically they should be dissolved in water to be an acid. And this would be hydrophosphoric acid. Does everybody see that I'm just following this formula? Hydro, whatever the other element is, ic acid. So those are binary acids. That's the way that I do binary acids. But oxyacids are going to be acids with polyatomic ions that have oxygen in them. So for example, the most famous acid here is H2SO4. And I can see right away that's not a binary, right? That's not a binary acid because I can see more than 2 letters. So this is the way that you name these. You say, you look at the polyatomic ion that it comes from, and this is sulfate. SO4 minus 2 is sulfate. That's the polyatomic ion sulfate. You can look that up in your nomenclature resource sheet. So the way that you name these is you don't say hydro. If you have a polyatomic ion that ends in 8, you just say the name of the polyatomic ion and ic, and then you say acid. So this would be sulfuric acid. If you had H2SO3, well, I look at my, and again, just to be nice, you like to put the AQ here just to make sure that you know that it is dissolved in water. So this one is sulfite, right? This is sulfite. That's one of your polyatomics that you should know that it's one less oxygen than the 8. Well, if it's an ite polyatomic ion, we say the name of the polyatomic ion and we use the suffix us acid. So if it's an ite, we say us. And so this is sulfurous acid. Okay? So let's do a couple of these and see if you guys can get the hang of it. So for all of these, I need to write the formula. All right? So this hydrocyanic acid is a little bit different. It doesn't follow the same rules because it doesn't end in 8. So that's why I did that one for you. But let's take nitric acid, okay? There's no hydro, so I know it can't be binary. And remember that if it's a binary acid, then you're going to say hydro, whatever the other element is, ic acid. If it's an oxyacid, so if it's from a polyatomic ion, if the polyatomic ion ends in 8, then it's an ic acid. And if the polyatomic ion ends in ite, then it's an us acid. Okay? So nitric acid, well, I'm going to go backwards. Nitric acid must have come from nitrate. And I know nitrate is that. So I know that I have hydrogen in the front, so I must have one hydrogen, and so this is going to be HNO3 parentheses AQ. All right, let's try another one. Actually, you don't need to do boric acid. That's just a little bit too hard. But let's try this one. Let's try perchloric acid. Well, perchloric acid must have come from perchlorate. And perchlorate, I know, is ClO4 minus. All right? And so I know that hydrogen is a +1, and so perchloric acid is HClO4 AQ. All right? Let's try this one. Let's try hydrobromic acid. Well, this is hydro. So if it's hydro, that means it's binary. And I know the other ion it's going to be hydrogen and plus one other ion, which I know must be bromide. And bromide has a charge of -1. And so this is just HBr, and then I put AQ. All right? So now let's try the formula to the name. All right? So let's try this one, for example. This looks like high, right? But I see that's a binary. This is going to be a binary acid, and so I'm going to use hydro. And then the other element is iodine, and then I say ic. So hydroiodic acid. So if you had written hydroiodinic acid, we would give you points for that because you're trying to follow the rule. All right, but let's try this one, for example. All right, so I know that's not a binary. It's not going to be hydro anything. This is going to be an oxy acid, and I can see that the polyatomic ion is CO3 minus 2. I can tell that because there's 2 hydrogens and each hydrogen is a +1. Well, I look at my polyatomic ion sheet and I see this is carbonate, right? That's carbonate. And so I'm going to follow the rule for oxyacids. An 8 is going to become an ic. And so this is going to be carbonic acid. This is hydroiodic acid. All right, so hopefully that helps, and I'll see you in class.